Yeah, and there's someone currently mowing the lawn, so hopefully it's not too noisy. I feel like in my neighborhood, there's always someone mowing the lawn at every point in time. Anyway, I'm Schatz. I'm a PhD student of John Laird's at the University of Michigan, and I'm presenting on initial research on learning causal relationships through instruction in Rosie. So humans can learn causal relationships from a single example and then use them to plan efficiently in the world. So for example, if he flips the switch and sees that the lamp turns on, he now has learned that causal relationship between the switch and the lamp. Humans can also teach each other these causal relationships with simple conversation. So let's say someone else comes by and wants the lamp to be on. He can now teach her the causal relationship between the switch and the lamp, and she can use that now to plan and figure out how to turn on the lamp herself. An AI needs to be able to quickly learn causal relationships in order to interact with the world in real time. So let's say a robot comes by and wants the lamp to be on, and we want this to happen in the near future, right? The robot doesn't have time to say run like thousands of examples and try to figure out these causal relationships. What we want is for the robot to be able to learn these efficiently and quickly with few examples. So current systems have causal relationships. They're called action models, but the action models are either hand-coded or they're learned through thousands of examples. So for example, Yang, Wu, and Zhang's work on learning action models from plain examples using weighted max sat. In their work, they go through thousands of examples of interactions and then use that to build up models. But at the end, those models still have to be checked by a person. And like I was saying, they use thousands of examples. So my solution is to first create a declarative representation for action models that can be easily learned and utilized by an AI. And then to enable the AI to learn these action models, both through interaction and through exploration with interaction. So I mentioned this was initial research. So far, I've done the first step where I've created this declarative representation, and I've enabled an AI to be able to use that representation for planning. And then I've also started the work on learning these action models through interaction. So I've implemented this solution in Rosie. So as you might have heard from the earlier talks, Rosie is an AI system built in SOAR. SOAR offers multiple learning mechanisms and memory mechanisms, which help Rosie do a wide variety of different tasks. So Rosie currently uses action models in forward search for planning, but the majority of these action models aren't currently being learned, and forward search can be slow, especially when there's lots of possible actions for the agent to do. And then Rosie also currently uses interactive task learning to learn new concepts, so this is a perfect place to kind of extend this work and learn action models as well. So here's the declarative action model representation that I came up with. We have the participants, which are the objects involved, the preconditions, which is the state of the world that needs to be true, the cause, which is the action that causes the effect, and the effect, that's the state of the world after the cause, given the preconditions. So here's a concrete example of the light switch model. So the participants, we have the lamp and the light switch. A precondition is that the lamp and light switch are connected and that the light switch is reachable. And note that these preconditions have to be perceivable by the agent in the world. So it has to be information that the agent can know. The cause is flipping on the light switch, and the effect is that the lamp is now on. So here's what that looks like in SOAR. So as you can see, it's pretty long, not super fun to hand code these. So it's not really feasible to say write 100 of these action models. So instead, how about we learn the action models? So for learning these declarative action models, we want it to be general. So we want to learn a wide range of models. We want it to be effective. We want to learn accurate models, but we also want it to be efficient. So we want to require a few examples. So the best way to do all of these is with interactive task learning, or learning these declarative action models through interaction with a person. So now I'm going to walk through an example of learning one of these action models through interactive task learning. So the instructor says something like, flipping the light switch causes the lamp to become on. This fills in the participants with lamp and light switch, the cause with flip on light switch, and the effect with the lamp being on. Rosie then asks, is there a precondition? The instructor says the precondition is that the lamp is connected to the light switch, and that gets filled in. Rosie can then ask, is there another precondition? The instructor says the precondition is that the light switch is reachable. Rosie can then ask, is there another precondition? And the instructor says no. And then the full light switch model has been learned. So once this model has been learned, Rosie can now use it to plan in the world. So for example, if the instructor says turn on the lamp, Rosie can now use this model to first ground the participants, so the lamp and the light switch, to the real world, check that the preconditions are matched. If they're not, Rosie turns those into the goal state and does further processing and planning. But if they are met, it goes to the cause, does that action, and then sees the effect, in this case, that the lamp is on. So another question, can we reduce the interaction required while keeping the accuracy of the models? And the way I found to do this is learning through exploration with interactive task learning. So this way, Rosie can try possible actions in the world, can then create a possible action model, but in order to keep the accuracy of the models, Rosie then verifies the action model with the person. So this prevents needing thousands of examples, but still enables Rosie to learn some things on her own. So this is kind of how I imagine this going. This is not implemented yet, but example one, learning a correct model. So the instructor says, explore the environment. Rosie plugs things in, flips switches, and notice that the lamp turns on, and so says a potential model is when I flip on the light switch, the lamp turns on. Is that correct? The instructor says yes, and then Rosie asks, is there a precondition? And the instructor says a precondition is that the lamp is connected to the light switch, and this can go on until all the preconditions are learned and the full model has been learned. And then here's an example of it going incorrectly. So the instructor says, explore the environment. Again, Rosie plugs things in, flips switches, and all of a sudden the lamp disappears from outside circumstances. And then Rosie goes, oh, a potential model is when I flip on the light switch, the lamp disappears. Is that correct? So in this case, the instructor can say no to prevent Rosie from learning the incorrect model. All right, so Rosie can now utilize declarative action models for planning, where before it had just normal action models, procedural action models that it used for forward search. Now we can use the declarative action models for means ends analysis. Rosie can learn declarative action models through interactive task learning, but learning with exploration is not yet fully implemented. And I'll now take any questions, Peter.
Okay, thank you, Jule. So far, I don't see any questions in the chat window. If anyone has questions, please post them there. We actually have about 6 minutes left before Charles Newton's time to start. So we have a little time gap here. John, do you have anything you want to jump in with?
No, I think, thank you, Jule. Thanks, James and Aaron. We'll take a 5-minute break, and Charles will start right at 11:35. So great. Thanks.
I think I see a question from Stephen. What are the next steps? So next I'm going to make the learning through interactive task learning more robust and make it work for multiple examples, or make sure it works for multiple examples, as well as finishing incorporating multiple preconditions. And then after that, I'm going to flesh out the idea for learning through exploration a little bit more, and then implement that. And that's all going to be done over this summer.